Hey everybody. You can see from the screen in front of you that what we're going to do is we're going to go through an equations review. So our goal today is let's try to review as many grade 9 equations, things we would have seen in grade 9 as we can, and just get back into shape with solving some equations. Okay, let's jump right in. So what you see on your screen then are two pretty entry-level equations from grade 9. I'm going to make the assumption that for a lot of us, this is about rust buildup. So at any time, pause the video and attempt any of the problems you see on the screen. I am going to go through and just give solutions to each one of them. Again, I assume that we're pretty solid with it. We're just out of shape with it. If at any point you start to feel comfortable, then pause the video. Try them on your own. See what comes back to you. Use these as a bit of a check. Okay, so what I want you to do, get started on the first two. Pause the video now. Okay, we're back. So I want to work my way through those first two, and I'm just going to address the first one. I'm hoping that our strategy coming out of grade 9 was isolate the variable term, then isolate the variable. So I see that I've got a variable term sitting there. I want to get that 5x all by itself, which means I need to get rid of any other term. So to get rid of that minus 4, then I need to add 4. And please feel comfortable to just add 4 to the other side and come in on 15. Now it's my job to try to isolate the variable. So that means I have to get rid of its coefficient. I have to get rid of a times by 5. We should be good. To get rid of a times by 5 means I divide by 5. There's my 3. I would love it if you showed those two blue steps. If you have steps in between, I'm going to call these safety steps. You know, a step that might have looked like this, or a step that might have looked like this. Then I'm going to put pressure on you to try to skip over those green lines and go just to the blue. Okay, hopefully that's a bit of a check. We matched up and we're jumping into B. I'd like to tackle B two different ways. And I'm going to call one way a left side variable way, where maybe you just feel like you always like to put the variable on the left side. And then I'm going to deal with a positive coefficient way. A way where you like to have a positive coefficient out in front of your variable. So let's take the first approach. So all I'm going to do is I'm going to come over to the left here, and I'm going to deal with this brown solution. If I was a left side variable person, then I would be motivated to say, I want to get all my variables onto one side, which means I need to get all my constants onto the other. So I would be motivated to say, I already have the 2x on the left. To get rid of a plus 4x, I need to minus 4x. On the right side, I already have a constant of 6. Then to get rid of a minus 7, I need to add 7. When I collect that, I'm going to come in on that line. And you'll notice that I have a negative out in front of my variable, a negative coefficient. So that's just going to add a little bit extra for me to consider. It shouldn't be difficult. It's just extra. Now for me to go through and solve that equation, to get rid of a times by negative 2, I'm going to divide by negative 2. And you'll notice I now have a negative on my denominator, which I can't have because negative numbers of groups don't make sense. So I would be forced to move that negative up onto the numerator, or say that the value of 13 halves is my value for x, the number portion, that is negative. Either of those two last forms are good. Okay, there's your solution to B. But that is a left side variable option. Okay, what I want to do then is I want to take a different approach. So I am going to go through and I'm just going to get rid of these little brown circles that I put on my equation because I'm going to take a different approach. I'm going to go through and I'm going to play with this the purple way. That is, I have a focus that I want a positive number of variables. I'm going to be a positive coefficient person. And so if I take a look at my original equation and I see that I've got 2x on one side and 4x on the other, then I might notice that if I were to put all my variables on the right, I would have a positive number of them. So my motivation then is going to be, let's get my variables on the right, which means my constants on the left. And if I was to go through and write that line down, then I'd have the -7 on the left. To now get rid of a +6, I need to -6. I already have the 4x on the right. To get rid of a +2x, I -2x. Now when I simplify or collect on that line, you'll notice I have a positive on my variable. And so now for me to go through and solve that equation, you'll notice it doesn't require the green line for any adjustment, because when I divide out my 2, I'm never putting a negative on my denominator. You would just jump straight to, and I can now get rid of that green line, and we're good. Okay, my goal for you is to be a positive coefficient person. You'll notice with me in class, I am going to be a positive coefficient person unless I just end up shutting my brain off and trucking through and put my variables on the left. But if my brain's firing at all, I'm going to be a positive coefficient person. Okay, hopefully those are not allowing you to knock off some rust. Let's keep building our review. Okay, you take a look at the next 2 problems on the screen. You know the job. Pause the video, give both of them a shot. We'll see how things match up when we come back. Okay, pause it now. Okay, we're back. So I'm hoping you took a look at both C and D and notice that really the only difference with these ones are brackets. So all I've done is I've added in some extra multiplication operations. I'm hoping our instinct then would be, let's follow BEDMAS on both sides of that equal sign, and we can expand our brackets. So if I multiply out on the left and I multiply out on the right, I've now created what's basically our easy one from B. Okay, if I am a positive coefficient person, then I am thinking about my variables on the right. Okay, you'll notice what I just said. I said I'm thinking about my variables on the right. Well, because I speak English and I write in English, then I write left to right. So even though I'm thinking about my variables on the right, I'm going to write my variables on the left. That will allow me in the end to say m equals a number rather than a number equals m. I've been asked to solve, so my statement should be my variable equals. Okay, I don't think that that's that big of a deal. If I'm picturing my variables going to the right, then I need to think about my constants on the left. Well, on the left, I would now have 10. Right, look back at my first line in purple. To get rid of a -3m, I need to add 3m. To get rid of a +2, I need to -2. Now, to get rid of a times by 5, I divide by 5, and hopefully we're good on the purple. Okay, same thing. If we had a hiccup on C, pause it, give D a shot. Otherwise, we're working our way through. We take a look at D. And you just notice that all I've done is give you more operations in your equation. Take your time, work your way using BEDMAS. So I could multiply my 8 in. Okay, here comes my trap. Multiply in my -9. Just make sure -9 times +2 is a -18. Be very careful on that when we make that expansion into the brackets. There's my multiply. Okay, my advice to you. When we go through and we try to isolate a variable, my advice would be simplify first. You want to do as few opposite operations as you can. So spend one line collecting your y's, collecting your constants. And now we get to this point, and now you can start to isolate. I notice that if I get my variables on the right, then on the right I will have 2y. That means I need to think about my constants on the left, which would give me a 9. Now when I divide out, I have my 9/2 and I'm good. I just think that this gives us one more opportunity to take a peek and just recognize what would have happened if we had been left side variable only. Notice you would have come in on a minus 2y equals negative 9. And now that would have forced you to have to consider signs. Your negative 9 divided by a negative 2, and a negative divided by a negative is a positive. It just gives you more stuff to consider. I'm hoping we've got the purple solution. Okay, hopefully we match up. And again, we're continuing to review. Let's jump into the next ones. Okay, you take a look at the two equations on the screen. Same thing. I want you to pause the video, jump in, and see where they go. Okay, pause it now. Okay, we're back. So you take a look at E, and I'm hoping E wasn't that big of a change from C and D. We take a peek. We've got some operations, so we're going to try to simplify both sides of that equal sign. When we do go ahead and we expand those brackets and do the operations, then we're going to get down to that pretty quickly. Now, your goal to be able to solve that equation is to be able to tell x equals what? So our motivation should be to isolate our variable term. Well, you notice you have variable terms that will not collect. But what we try to do is get all of those on one side. So if I imagine everything going to the left side, because I'll have positive numbers of them, what you will notice is that you're going to end up getting this. And what I really want to highlight for you is this beginning part. Notice your x squareds, they're going to cancel out. So can we go back up to the purple line, and can we see that when I have an x squared on one side and an x squared on the other side, when I collect those on either side of my equal sign, they're going to cancel out. So let me get rid of that blue line now, and maybe we can see why on my left side, that's going to simplify to 7x. And my constants on the other side will get to there. So now, when I solve for x, I come in on my negative 11/7 pretty efficiently. Okay, I want you to take a look back on E now, and notice we may have hesitated a little bit after we expanded those brackets because we had squared x's and single x's. I hope we notice, no big deal. Okay, maybe this is an opportunity to pause the video and give F a try. Otherwise, again, you're coming along with me. So in question F, we're going to tackle the same thing. Let's try to simplify as much as we can. So I'm hoping that I can even just stop drawing those arrows because we just know to do multiplication, expand your brackets. So I get my 6x squared minus 6x minus 18. And on the right side, a 4x squared minus 4x minus 2x. Okay, I'm going to spend one line collecting. It is well worth it. So if I was to put this line down, we may notice that there's not much collecting that can occur, only at the end of that right side where we can get a negative 6x. But we may now see that on each side of my equal sign, I have a negative 6x. And so regardless of what side I would bring both of those to, they're going to cancel out. So I'm going to just write this line down just so we can see that what we would end up having is a 6x squared on the left. We're going to want to get our x squared terms on one side. So to get rid of a plus 4x squared, I minus 4x squared. Then that gets minus 18, gives me a plus 18. We could clean that equation up pretty quickly to that. Okay, here comes your big trap. And I want to talk a little theory right now. You'll notice our next step would be to get your variable all by itself. The problem is we have two things attached to the variable. The first one being the coefficient of 2, the second one being the exponent of 2. Okay, my advice to you would be get rid of the coefficient of 2 first. I'm going to show you why. If I go through and say, well, to get rid of a times by 2, I'm going to divide by 2, then I could take this purple solution that would say x squared is going to equal 18 divided by 2, which is 9. Okay, well, now I could finish off the equation, and to get rid of my squared, I'm going to take the square root. The only thing I need to make sure I remember is every time I take a square root, every time I do, I could have two possible answers, a plus or a minus. And so when I go through then and calculate the square root of 9, I get 3. So I actually have two solutions to that equation, positive 3 or negative 3. And if you were to do a check and go back, you'll see both of those work. If we were even to do a quick check back into here, you'll notice 3 squared is 9, but also negative 3 squared is 9. Negative 3 times negative 3 is also positive 9, so we have to make sure we do not forget about that solution. Okay, that purple root is the root I would take if I were you. Okay, so what's the other root? Well, I'm going to take this pink solution off to the right. That maybe what we looked at is we looked at that exponent 2 and said, hey, let's get rid of the exponent 2. Okay, I'm going to write something incorrect down. This would be my next line with an error, with the common mistake. Is that I think a lot of people would end up saying, well, to get rid of a square, then I take the square root, and I have the square root of 18. Okay, well, now to get the x all by itself, I have to divide that by 2. So I get plus or minus root 18 divided by 2. And that's not the same answer as plus or minus 3. Now, we're not there yet with some of our algebra. But what you can do as a check is go ahead and punch that pink into a calculator and see we don't get 3. Okay, so where was my mistake? Okay, I'm going to erase that pink. My mistake was in looking at the equation 2x squared equals 18. I forgot that what I'm really doing is the same operation to both sides. And I made the mistake that to get rid of a square isn't to take the square root of that power. Look at where that pink square root is. And do you notice we didn't take the square root of the 2 anywhere? So in fact, when I then took the square root of both sides, my 2 pinks, I didn't take the square root of the left side. My equation is no longer in balance. Okay, so how do I fix it? Well, I'm just going to write that equation out one more time. And what I can do is follow the pink. Which means if I'm going to calculate my left side or simplify my left side, I would get the root of 2. The square root of x squared is x plus or minus the root of 18. That pink line is now correct. It's ugly, but it's correct. So if I then divided out my root 2, because to get rid of a times by root 2, I'm going to divide by root 2, I now get the pink on the right side. Ugly again. Okay, if we wanted to push buttons on our calculator just because we're a little ahead of where our numeracy has us, you'll see that that gives you plus or minus 3. Okay, take a look at your screen right now, and you decide which way you'd rather solve that. I would hope for most of us I've won you over to the purple. That when you have a single power like that, the best thing to do is to get rid of your coefficient first. Then deal with the square. Okay, I'm going to just make sure we can see that whole problem as best as we can. Okay, I think that that's built up some pretty ugly stuff for us. Let's jump into a couple more finishing problems. Okay, you take a look at the screen now and you'll notice that I've given you 2 equations that contain fractions. Okay, we'll see what we remember. We'll see how comfortable we are. Pause the video, work your way through those 2. Okay, pause it now. Okay, we're back. As I mentioned at the beginning, I'm going to walk my way through this assuming you know what you're doing. Again, this is review. So I would hope for most people our goal would be to eliminate our fractions, which means I'm going to put brackets around every term so I can put in a multiplication operation on both sides. If I take a peek, to get rid of a divide by 2, I times by 2. To get rid of a divide by 4, I need to times by 4. But there is a 2 that exists in a 4. I've got a factor of 2 in there, so I can get rid of that 2. A 4 will take care of it. And I need to include a factor of 3. What I just found is if I multiply everything by 12, then I can eliminate all of my divide bys. So I'm going to put in a little times by 12 on every term. And now I'm going to go through and simplify each term first. So 12 divided by 2 is 6, 12 divided by 4 is 3, and 12 divided by 3 is 4. No part of you should be surprised that all those divided evenly. You chose 12 so that they would. In fact, if they don't divide evenly, then you know you picked a bad value to multiply by. Okay, now that we've got that, let's simplify every term. 6 times x, 3 times 3x, 4 times 5. You can see your multiplication right up there. And now we've got the easiest of easy. 15x is going to equal 20. X equals, please avoid just writing that down. I would call that a reflex action. But instead, jump straight down to that fraction, fully simplified to 4/3, and you are good. Okay, if we were a little stumped on that first one, and now it's come back to us, then let's give h a shot. Okay, pause it now. And we're back. Okay, I take a peek. If I make the mistake of just looking at my divide bys, then I may be tempted to multiply this first term by 10 and this first term by 10. But then you'll notice I forgot about my 9. So my advice to you always is as soon as you have fractions in there, put brackets around every term. And then you won't forget to multiply, especially if they don't contain a fraction. As soon as I put brackets around every term, then it makes me want to write times by 10 on every term, and I won't forget about the 9. Okay, we're going to do our division first. 10 divided by 5 is 2. Nothing to divide by with the 10 and the 9. 10 divided by 2 is 5. Okay, this is where you need to figure out if you make a certain mistake. If your next line would have been this, 6x equals 90, and now I'm going to multiply into both terms on top, and you wrote down minus 15x minus 50, then I'm going to suggest writing a line in between. We made a common mistake there. Okay, what's the line I'm talking about? Well, you can collect when it's one term, a monomial. Collect again when it's a monomial. But as soon as you get to expanding into a binomial, if you write that down, then you are less likely to make your mistake. And I'm hoping you can see how the red does not get me to the purple with the binomial. Oh, shoot. When I now take that 5 or negative 5 and I expand it into negative 10, then I should have got a positive 50. I think if you write down the red line, you're less likely to make the purple mistake. Now that our purple's corrected, we should be quick to finish it off. Get your x's on the left because they're positive. The right now becomes 140. X is going to equal. Now, you write down this, and here's where you may be tempted to just walk away from the problem. Look back on your solution to G. See how I wrote in green 20 over 15? I'm going to fight the urge to write it because it's so easy to walk away with an unsimplified fraction. I take a look at 140 and I look at 21 and I say, do I see common factors in there? Well, 21 is made up of 7 and 3. So all I'm looking for in 140, is there a 3, is there a 7? Well, there is no 3 because my digits don't add up to 3, but you go, oh shoot, there's my 14. Yes, I can divide that by 7. So then we reduce by dividing the top by 7 and the bottom by 7, and you are good. Okay, be careful on that. Make sure we're always reducing. There we go. Okay, so you've got a full equation review now for isolating your variable. I'm hoping today you can jump in and with a little bit of practice, we've knocked off all that rust and things go smoothly. Okay, best of luck.